In this video, we are going to look at how to find the position of center of mass for a system of particles. We have got three masses here, m, 3m and 5m, and their position is shown on the x and the y axis. We can check the coordinates for each one of them from the x and the y coordinates, which we can read from the coordinate axis. Because we want to find the position of center of mass, the first thing what we will do is we will write what are the coordinates for each one of the masses. So for m, we can see it is 2.5, 3. That means 2.5 on the x-axis and 3 on the y-axis. Once again, let's just double check it. It's 2.5 and 3. Then for 3m, it's 1 because it's on the x-axis, and on the y-axis is just 0. So 1, 0. For 5m, it's on the x-axis, so it will be 5, 0. Now we can apply the formula for center of mass, that is xcm, m1 x1 plus m2 x2 plus m3 x3 over m1 plus m2 plus m3. Let's write the coordinates and the masses. Now, because we are focusing on xcm, so we will just focus on the x coordinate. So m multiplied by 2.5 plus 1 multiplied by 3m. So you can just switch it the other way, it doesn't matter. So we'll first write the mass and then the coordinates. So 3m multiplied by 1 plus 5m multiplied by 5 over m plus 3m plus 5m. Now let's just write this down in a simplified manner, whatever we can simplify. So 2.5m plus 3m plus 25m. 5 times 5 is 25. So 1 plus 3 plus 5 will give us 9m. And then we can add the numerators, the numbers in the numerator. 2.5 plus 3 plus 25. That will give us 30.5m over 9m. M can be cancelled and we can simplify it further. We will get the value for xcm. And let me just use the calculator. That comes out as 3.39. So that's our answer for xcm. Now that's xcm. We also want to find what is ycm. So let's just make some space, move this aside. Ycm is equal to m1 y1 plus m2 y2 plus m3 y3 over m1 plus m2 plus m3. Now we will focus on the y coordinates. So we can write the first one is m multiplied by 3, and then the other two coordinates for y, y2 and y3, they are 0, so it will be just 0. Anything multiplied by 0 is 0. And then in the denominator, you will have all the masses, m plus 3m plus 5m. Then we can get this as 3m over 9m, which is further simplified to give you as 1 over 3, which gives you the answer 1 over 3 is 0.33. So we have got the coordinates for the position of center of mass, which is 3.39, 0.33. In this problem, we are going to look at an irregular shaped lamina. So here an irregular shaped lamina is balanced at pivot O. So pivot is the point where it is balanced. That means that is its center of mass. And we know that center of mass is the point from where the weight of the object or the body seems to act. Now we have got two masses, 2 kg and 4 kg, which are also kept on the lamina. It's asking you where a third mass of 1 kg should be kept so that we can balance the system again. Now with the figure, we also have the coordinates given for each one of them. If it's not given in the problem, you can find from the diagram because we can read the graph and find out what are the coordinates for each one of them. Now we are going to look at the formula for XCM, and you can see that 1 kg, the coordinates are not known because we want to find where it should be kept. So we'll write that as for 1 kg, we are writing it as x comma y. Now the formula for XCM, m1 x1 plus m2 x2 plus m3 x3 over m1 plus m2 plus m3. Now we can look at the coordinates and take the x coordinates, multiply with the masses and put it into the formula. So XCM is -4, and then we have 2x multiplied 2 multiplied by -8, 4 multiplied by 1, and 1 kg, we don't have the coordinates, so we'll write it as 1 multiplied by x. And then in the denominator, we just add all the masses. We can simplify this further to get the value for x. So we can see that this will be -28 equal -12 plus x, which we can further simplify to get the value for x, and that will be equal to -16. So we have got the x coordinate. Now we also want to find the y coordinate. So let's just move this aside. Now for the y coordinate, we'll repeat the process. YCM is equal to m1 y1 plus m2 y2 plus m3 y3 over m1 plus m2 plus m3. And then we can look at the y coordinates of all the masses as well as the center of mass, which is the pivot, and substitute that into the formula. So 1 equal 2 multiplied by 3 plus 4 multiplied by -1 plus 1 multiplied by y over 2 plus 4 plus 1, which is 7. And then we can simplify this further to get the value for y. So y will come out as 5. So now we know that 1 kg mass should be kept at a coordinate of -16, 5, so that we can again balance the lamina.